Ozone high in the atmosphere is sometimes called good ozone because it filters out harmful radiation from the sun. But on the ground, ozone caused by pollution is a health hazard, making it harder for many people to breathe. In this movie, we'll use TinkerPlots to explore how things like temperature affect ground-level ozone. These data were collected in New York City for 111 consecutive days from May to September in 1973. For each day, we have information including ozone level, temperature, and wind speed. Let's look at temperature. With temperature selected, pull up to fully separate the cases. Up here are the hotter days. Let's look at how temperature varies day by day. Select day and drag right to fully separate. Let's color the circles by temperature. On the first day, the high temperature was 67 degrees. Here's the second day. Over here is the final day, day 111. Adding connecting lines helps us to see how temperatures varied. Even though the temperature fluctuated a lot from day to day, we can also see a trend with temperatures generally getting higher through June, July, and August, and then falling in September. Because this type of graph shows how something changes over time, it's called a time series graph. We frequently see these graphs made of bars, which we can show by changing the circle icons to value bars. Here, the bars for hotter days are both longer and greener. Let's look at ground level ozone by dragging ozone from the data cards onto this axis. Now, the height of each bar shows ozone level. Days with ozone levels above 120 pose health risks. Even levels above 50 can cause breathing problems for some people. Here's a day when the ozone level was quite high at 115. This was on day 23. Here's a day, day 18, when the ozone level was rather low. Let's look at these data using our circles and connecting lines. Just as we saw with temperature, ozone levels were generally low in May, increased in summer, and then fell again by September. Let's make the circles a little larger and remove the connecting lines. Let's look at ozone level by itself. Remove day from the bottom axis by turning off the Separate button. Let's stack the icons. The ozone levels cluster around 20, with fewer cases at these higher levels. Did these high ozone levels tend to occur on hotter days? To see, color the icons with a green temperature gradient. Notice how, as we move up the ozone scale, we tend to go from the lower temperatures, the lighter green, to higher temperatures, the darker green. Let's pull a case to the right to separate the temperatures into two bins. For days that were 79 and below, the majority were within safe ozone levels. For days above 80 degrees, about half had ozone readings over 50. Making the bin smaller might give us more information. Let's stack the cases vertically and display the median ozone level of each bin. We'll summarize what we see using the drawing tool. As we move along here to higher temperatures, the median ozone level doesn't change much. But once we get here, as the days get hotter, the median ozone goes up by quite a bit. If we fully separate temperature, we get a scatter plot. The line we drew through the medians fits rather well through the center of the scatter cloud. These points are clearly exceptional. They have much higher ozone readings than we'd expect. Coloring the icons by these other attributes might suggest an explanation.